So basically we are doing the school derivation for that particular thing. What we did, we considered an object of mass m, a simple bob, and simple pendulum bob, and we threw it with a velocity u at the bottom, and it completed the whole circle. We need to find out this minimum value of this u so that we can so that this whole thing can complete a vertical circle. Okay. Now for this particular thing, I told you this particular tension will be different at different points. So let's say the tension at bottom is T bottom and tension at top is T top. Okay. At the topmost point, mg will be acting down. T top also will be acting toward the support, because in all the cases the support will be at the center. And here in this case, when it is at the bottom, the tension will be acting upwards and mg will be acting downwards. So basically we are trying to draw the free body diagram at different places. Similarly, at bottom, can I say this particular thing, that this object of mass m is moving with a velocity u, and at this particular instant what all forces are acting on it? Mg is acting downwards and tension bottom is acting upwards. Okay, yes or no guys? We know the condition to complete the circle is basically what? T top should be greater than equal to 0. So just we need to find out the value. Now can you see over here mg? Yes, can anyone tell me what will be the this thing? Can you say these two forces, since the center of the circle will be over here at this point, here in this case the center of the circle will be over here. So can you say in this particular case these both forces are together giving you what? The necessary centripetal force. So T top plus mv square by L should be equals to, oh sorry, my bad, T top plus mg is giving you equals to mv square by L. These two forces are together giving you the necessary centripetal force. And at the bottom, what is giving? At the bottom, T bottom minus mg is giving you mu square by L. Right? Yes or no, guys?
Yes, sir.
So we'll take the limiting case. For limiting case, the tension at top will be, zero. The limiting case is basically this. The minimum case is, when we consider the minimum case, we consider the tension at the top is 0, right? So at that particular instant, by equation 1, can I write mg is equals to mv square by L? And from here, can you see v square is equals to under root of gl? So can you see, to complete the vertical circular motion, the velocity at the topmost point should be how much? Under root of gl.
Yeah.
Now by applying work energy theorem, or in spite of using work energy theorem, we can use directly by the energy conservation law. At points A and B, what is the A point? A point is at the bottom and B point is at the top, right? Or in spite of considering it as A and B, you will just consider it as P and Q. It will be much more simpler. Otherwise, you will confuse with the bottom. We are taking the top at B and all. That's a much correct. We'll just assume that we are applying work by energy or energy conservation law to points P and Q. Now at the bottom, can anyone tell me what will be the total energy at the bottom? The total energy at the bottom will be, kinetic energy is how much?
Half mu square, sir.
Half mu square. Any potential energy? 0.
So 0.
Kq square, kinetic energy half mv square plus qq will be mg. And what is the height, by the way? Can anyone tell me the height?
So diameter.
Diameter, will it be equals to twice of L?
Yes, sir.
So this will be mg into 12. And we just know what is the velocity of v top under root gl. So from here, half m into gl plus mg into 2l should be equals to half mu square, and when you solve it, u will be equals to how much? Under root of
root 5 gl.
So please remember, this is the minimum velocity. Since tension will always be greater than 0, right? greater than equal to 0, so minimum velocity, this is the minimum velocity. So the final result will be to complete the vertical circle, the velocity, and that too the minimum velocity with which an object shall be thrown is under root of I. This was the derivation which is there in your school. Clear? Please write them. Acha, from where do you need to write? You need to write from the starting, or have you completed till here?
So starting.
From the starting. And please remember, this statement is very necessary. People give marks for this. Hai na? If you have a 5 marks derivation, they will give you 1 mark for this statement. Whenever you write words in a derivation, no, then teacher knows कि हाँ भाई इसको आता है. So from the first statement, they start, they lower their guard. Okay, they might be knowing this particular thing. So, sometimes, you will get, just tick, tick, tick. And, even if your derivation is wrong, the last thing and the first thing, it made a good impression. So whatever you do in between doesn't matter. Sometimes it happens, you know. So at least keep your presentation skills open, at least when the time you are writing school.
So done with this part.
And Acha, can you see over here? Can anyone find what will be the tension at the bottom? Can you say u square will be under root of 5 GL, and so when tension is 0, you can find out the tension at the bottom as well by equation number 2, in case if they asked. है ना? So I guess the derivation is pretty much clear. Okay.
Yes, sir.
Everyone noted down till here? Completed the whole
Sir,
thing?
please.
Scroll
Sir,
down, scroll
little
down.
higher. Yeah. Yeah. Sit on.
And the whole thing or till here?
Settle that. Done, sir. Just a statement at the bottom. Finish, sir.
Chali, after this, acha, what if I replace the string with a light rod? So vertical circular motion of a pendulum with a light rigid rod. In spite of having the string, if I have a light rigid rod, what is the only difference over here in this? The only difference is basically I have replaced the string guys. I think my OneNote crashed. Just give me 2 minutes. So light rigid. So there is a light rigid rod. Light rigid rod basically means what? This rod will not have any mass of its own, right? Or if it has a mass, it will be very small. So let's say there is a bob and you have a light rigid rod, and now you need to find out the minimum velocity with which you should have thrown this thing so that it completes a vertical circle, right? So the case one, do you remember case one? When the velocity is under root of 2gl, what will happen when the velocity is under root of 2gl? This rod will exactly go at 90 degree and then it will come back, right? So it is the same as that of with the string. Case 1 is same as that of the string. Case 2, do you remember case 2 guys? When velocity of under root of 4gl, when velocity of under root of 4gl, then what was happening in that case? What was happening in that case, guys? The rod was becoming, the string was becoming loose at an angle of 131 degree, right? And due
Yes,
to
sir.
which it fell because the tension was becoming zero. Now since it is a rod, do you think it will ever fall? The tension
No,
in a
sir.
rod
Just
can never be zero, right? So
right,
at
sir.
this particular instant, even if the tension becomes zero, so here the tension which was becoming zero in the case of string will never be 0 in this case. Why? Because the rod cannot slack, right?
Yes, sir.
So even if u is equals to under root of 4gl, do you remember the theta phi which came for where the velocity became 0 was basically the topmost point? Yes or no? So if u is equals to under root of 4gl, then the rod will become completely vertical again. And one slight push at the top position will bring the rod down for a complete circular one. So when the velocity is under root of 4gl, please write this thing. I'll draw this case. Suppose if this is the vertical circle, this is the rod, and you have thrown it a velocity of under root of 4gl, then this rod will become like this. And here the velocity will become 0. So are you getting my point, guys? Exactly what will happen in the case of a rod? It will complete the whole circle till if I give a slight push, then it may move again, right? Yes or no, guys? Why does this happen? Because the rod never slacks. Rod कभी ढीली नहीं पड़ती. The string can become ढीला, but not the rod, right? And then case 3, when velocity is under root of 5gl, it will be the same as that of the string case. Can you see in the previous case the velocity was under root of 5gl, the minimum velocity. Now here the velocity is under root of 4gl. So is it clear, if I replace a string by a rod, then what will happen? Yes?
Yes, sir. I'll complete a circle.
ठीक है. So the rod, whenever it is rod, it will complete a circle at velocity under root of 4gl. In spite of 5gl, under root of 5gl, it is completing at under root of 4gl.
So, but at 4GL, it'll go either way, right? Either forward or backwards, because it's velocity as you
Depends.
see. Oh, wait,
Where
momentum
you
carries it
are
through.
giving that slight push.
Yes,
What
sir.
time if I
Or
have
just,
thrown it with a velocity of 4gl, then it will go and become rest at this particular position. It will come at rest. Can you
yes,
see
sir.
velocity 0?
Yeah.
So wherever you push it slightly, it will move in that direction. Done? Guys, are you done? Arnav, you are in IB board, right?
No, sir. CBSE only.
CBSE only.
So JS's IS is IB. I'm in JS's PS, private
Sure,
school.
private school. Okay. You might have one senior, Ishita. She's also from JSS private. In 12th grade.
In 12th grade,
Here.
not so, not sure, sir.
Now, circular motion of a body inside a circular track. Suppose, guys. Oh, sorry. Can you see a circular track, guys? Suppose this whole circular track is very smooth, and there is a block of mass m which I have thrown with an initial speed u. So can you see, since it is smooth, to till the block will reach at the bottommost point on the circle, it will go with a velocity u, right? There will be no change in its the velocity. Yes or no? So suppose, can you see this block is moving, this body is moving inside this circular track? Yes or no? Hello? Hello?
So we can hear. I'm just
Uh, So see, guys, if I
confused.
if I assume this body is a point object, then at this particular instant when it reaches at an angle theta, then it moves with, let's say, a velocity or v in this direction, right? But due to the circular track, it will complete the circular motion. So can you see it is just as similar to this case? Can you see this case and this case is almost similar? What was the force which was acting over here? The tension. And in this case, there won't be any tension since the two objects are in contact, then there will be a normal reaction. Yes or no? Yes or no? So can you see both cases are equivalent to each other? The only difference is, however the tension was behaving in the case of a simple pendulum, here that normal reaction will behave, right? Can you see if it goes to a height h, so everyone knows the formula for h. Here the formula for h was what? H was equals to L into 1 minus cos theta. Here L is not there, here R is there, so here R will be R into 1. Yes or no? I can give using the same thing, using work, not necessarily using law of conservation of energy. Half mu square shall be equals to half mv square plus mgh. This will be equals to half mv square will be equals to half mu square minus mg into r into 1 minus cos theta. M will get cancelled out, and from here v square will be the same. Guys, can you see this? It is having the same formula what it was having in the case of, guys, can you see this case and the string case is similar? Yes or no?
Yes, sir.
At any angle at theta. Please write it till here. Itna likh lo. Draw the diagram very well. It's a smooth circular track of radius r. Done. Done, guys.
Yes, they're done.
Yes, sir.
So suppose the normal reaction is this, mg is acting downwards, this angle is theta, velocity is in this case, I can resolve it into two components, mg cos theta and mg sin theta. So already we did, right? And the object is moving in that direction with a velocity of v. So here n minus mg cos theta will be equals to mv square by r, and when you'll put this v square over here, the final formula will be mu square by r plus 3mg cos theta minus 2mg. So the formula is similar to tension? Yes, it is. So even the formulas are same, and even the cases will be also same. So can anyone brief me about the cases? What will happen if you throw this block with a velocity of under root of 2gl? Then it will go till this 90 degree and then it will come back, right? Yes or no? If you throw it with a velocity of under root of 2gl, this block will go from the top and it will reach over here and then it will come back, right? Similarly,
Yes.
if it is thrown with under root of 4gl, then it will go to an angle of 131 degree, where in the previous case the tension was becoming zero. Here what will become zero? The normal reaction will become zero at 131 degree. So at 131 degree, the contact force between block and the track will become zero, and that implies the block will lose contact with the track, and hence it will fall in a projectile motion, just like what it did in the case of string, right? Yes or no, guys? What is the third case? The third case is when it is under root of 5gl, then it will complete the whole vertical. So I guess the cases are also similar, so I don't need to discuss it. Yes? Yes or no? Is this clear, guys? Is this case clear? This is the same as string, right? All of this is advanced, J advanced. For those who preparing, and neat as well. Direct cases, direct, questions based on cases, okay?
So out of all of this, only that
Vertical
the
circular
string
motion.
is
Huh?
there for CBSE.
Only that derivation is there for CBSE. The school derivation which you did now?
Sir, I only wanted CBSE classes.
No problem. Only this topic, vertical circular motion, is like this, which is having more advanced as compared to CBSE. Rest everything will be like, CBSE, J will mixed. Okay? So only one derivation was there. तो डरने की जरूरत नहीं है. It's okay. समझ में आ रहा है ना? Is it like going like too high above?
So it's fine. Understandable.
Understandable. And at least just understand this as a story. This will happen in this case, this will happen in this case. Don't need to mug it up, no need to mug up the formulas and all. You just need to remember the interpretation, final interpretation which I gave. When the velocity will be this, then what will happen? When the velocity will be this, then what will happen? Just remember it like that. Khatam. Okay. So, anyways, inside the track is done. Let's try to do it outside the track. Earlier also this. Guys, will you give me 2 minutes? Let me just shift my, all the stuff to another bed. Some repairing work is going in my bed, near my bed. Okay?
Yes, sir. Yep.
Yes, hello people. The port near my bed, it got, something happened. I think some short circuiting has been happening, due to which, the 3-pin which I have fixed over that, it got stuck inside the port only. So now it is not even coming out, or now, even that port is not working. So I think some short circuiting की वजह से वो अंदर ही चिपक गया. So let's see. The technician is here, so I had to shift to another bed so that he can repair that. Anyways, last heading, vertical. What just happened? Last heading, vertical circular motion outside a circular track. Now, suppose you have a object, or you have a circular track, and let's say this object is placed at the top. Okay, there is an object M which is placed outside a circular track. Now what will happen when you give some velocity to the object? When you give some velocity to the object, this object will travel on the circular track. So let's say at a distance, basically at an angle theta, when it is over here, the forces acting on it are the normal reaction, which is acting perpendicular to the surface. Everyone knows how to draw the direction for normal reaction, right? Mg is acting vertically down. So if this angle is theta, then this angle will also be theta. If this will be theta, then what will be the case over here? What will be the case? Here mg can be resolved into two components, mg cos theta and mg sin theta. So can you see over here, when the object is trying to come down, at every instant this sin theta is trying to accelerate it, yes or no? Acha, what will be this height again? Can you see, if this is theta, this is r cos theta. If r is the radius of the circular track, then again this height will be r into 1 minus cos theta. And if people ask you what is the velocity at this particular instant, if I say the velocity is v, if this is moving with the velocity v, we'll draw tan it over here. So here n minus m, sorry, my bad. Mg cos theta minus n will be equals to mv square by r. Yes or no? Can you see, mg cos theta is acting into the towards the center. It is acting away from the center. For net centripetal force will be towards the center only. No, that's why I did mg cos theta as big and n as small. So mg cos theta minus n is basically this. This is your first equation. We'll use this equation later on, and you can use energy conservation at point A and B. So the kinetic energy at A plus initial potential energy at A should be equals to kinetic energy at B plus the potential energy at B. Where shall I assume the reference, guys? Shall I assume the reference to be here on the lower part at point B? If I assume the reference at B, then the potential energy at B will be 0. Kinetic energy will be half mv square. Here UA will become mgh and this will become half mu square. So from here, when I solve this particular thing, half mv square will be equals to half mu square plus mg into r into 1 minus cos theta. When I solve it further, v square will be equals to u square. Only difference is, can you see, the whole thing is still same, but in spite of a minus sign, a plus sign is here. No need to mug up the formulas. I'm still telling you, no need to mug up the formula. You just remember the result. Okay. And similarly, when you'll put this v square in the equation number 1, substituting value of v in equation 1, when you'll do it, you'll see that the normal reaction is 3 mg cos theta minus 2 mg minus mg square. Please write it. Shall I move it up? Sorry, with this thing, I'm done with all the vertical circular motion bits. Let's do some questions and just write down the derivation. And we'll see some questions, okay? First, let's do some questions on this thing. The simple pendulum cases. Yes, whenever you can.
So done with this.
Let's scroll down.
Yes, sir.
Hello. So, shall I give you a question, guys?
Yes, sir. I guess. Or we can do center of mass, sir.
I will do center of mass. At least question I can give it on this thing. This thing not connected. And please remember, if you don't even remember the formula, don't no need. Just see what conditions are given to you, and automatically you'll get the answer. If you can't remember the formula, no, there's no need to remember it or mug it up. So suppose there is a simple pendulum bob, length L is projected horizontally with speed under root of GL. I'm not throwing it with the speed of under root of 2GL, I'm throwing it with the speed of under root of GL from the bottom. Now question is, find the speed of the particle and the inclination of the string with vertical at a point where the string becomes, where the tension in string becomes equal in magnitude. Hello, hello, hello guys, hello, hello guys, can you hear me? Hello, guys, can you hear me? Hello, hello. Hello, everyone is on mute. Can you hear me? Hello, guys, can you hear me now?
Yes, sir. We can hear you.
So Wi-Fi issue or battery issue or what issue, sir?
No, Wi-Fi nahi. I told you na the people are coming to repair things. Electricity there. So he actually, he switched off the internet router.
Oh, okay.
So where the tension in the string becomes equal to the weight in magnitude. Chalo, start. So basically, suppose the question is, I'll explain it to you again. This is the support, and let's say this is the bob, whatever be the mass, you will be throwing it with a speed of u, which is equal to under root of gl. Okay, you need to find out that angle and that velocity at this instant. You need to find out this instant velocity when the tension in the string, the value of tension is equal to the weight. Okay, so the question is basically find the value of theta and v when tension is equals to mg. Okay, everyone understood the question? Hello. Hello.
Yes, sir. Understood.
Take it. So find theta and v when t is mg. How will you do it? Even if you don't remember the formula, you know how to solve free body diagram. Everyone remembers free body diagram, right? Are hayana? So this will be t in that direction. Here in this direction will be mg. So here it will be mg cos theta. So here it will be mg cos theta. So the first equation which will be there will be t minus mg cos theta is basically equals to mv square by L. And we also know by work energy theorem, what is this height? L into 1 minus cos theta. By trigonometry, we already did this. So we can find out the value of V as well. So half mu square plus 0 should be equals to half mv square plus mg h, which is 1 minus. So from here, the velocity will be equals to half m u square with the here. समझ में आ रहा है guys? Even if you don't remember the formula, it's okay. It doesn't mind. It doesn't matter. क्या रेंज आ रही ना वो कर रही है ठीक. So u square will be equals to under root of gl. So hence u square will be gl minus 2gl into 1 minus cos theta, and this is the velocity, right? Can you find out the velocity, guys? Velocity in terms of theta. Or basically, can you see from here, guys? Can you see from here? I can substitute. I can put this v over here and I can get my answer. So from here, when I solve it, velocity will be mu square by L plus 3mg cos theta minus 2m. Even if you don't remember the formula, it's okay. You can derive it at an instant. Once you derive it at an instant, now what is the condition given to you? The tension should be equals to what? Mg, right? Yes or no? So the tension is equals to mg, the tension which is equals to mu square by L plus 3mg cos theta minus 2mg. I can say this tension is equals to mg. Now can you see over here? I can solve it. And from here, can I obtain the value for theta? This mg will go to that mg and become 3mg again. This L and L will get cancelled out, so it will become mg plus mg, 3mg cos theta. So this mg, when it will go in that side, it will become twice of mg. So twice of mg is equals to 3mg cos theta. And can you see mg and mg will get cancelled? So from here, the value of cos theta is 2 by. Okay, and you'll put this cos theta in this formula to get the value of V as well, right? So T minus mg cos theta was equals to mv square by L. The tension at this stage is mg minus mg into 2 by 3 equals to mv square by L. And can you see from here you can find out the value of V? Yes or no? When you will calculate V, it will be under root of GL by 3, and that will be your answer. So can you see from the given data I can find out the theta as well as the velocity. Clear? Easy question. And please, I'm telling you still, don't worry about the formulas. The only thing which you need to remember is basically what? What is the pointer? The only thing which you need to worry is basically what? Applying free body diagram and applying work energy theorem, or basically the law of conservation of energy. The only thing which you need to bother is that only. Clear? Is this clear?
Yes, sir. Yeah.
Shall I give some homework questions?
So, and related to this itself?
Related to string, 2 questions homework. And
Sure, sir.
I know you people don't like homework, but still, at least 2-3 questions to kar sakte. A simple pendulum oscillates in a vertical plane when the bob passes through the mean position the tension in the string is, so you don't even need the formulas for this question. You can do it now only. The tension in the string is 3 times the weight of the bob. So basically, when the string is at its lowermost position, the weight of the bob is how much? The tension in the string is 3 times the weight of the bob. So what is the angular amplitude of string from vertical? So do you remember, okay, sir, I gave one formula for angular amplitude. The formula was basically what? Pi is equals to cos inverse of 2gl minus u square divided by 2gl. But sir, you said कि no need to remember this formula. हाँ ठीक है, मत करो, कोई दिक्कत नहीं. Don't do it by this. Just draw the diagram. And what did they say? At the bottommost position, when the string has its bottommost position, let's say it is moving with a velocity u, and let's say the tension in the string is T. And then what did they say? The tension, they said it to be 3 times that of the weight. So tension ऊपर की तरफ है, mg नीचे की तरफ है. So can you see over here, T minus mg is equals to mu square by L. And from here, 3mg minus mg is equals to mu square by L. And from here, u square will be, can you see, twice of mg into L. And m से m कट जाएगा. So velocity is under root of 2gl, right? If the velocity is under root of 2gl, then tell me कहाँ तक जाएगा? Till where this bob move? What will be the angular amplitude in that case? I told you, no, this is the case 1. Can you see? It will move to
That will be 90 degrees.
90 degrees, and that is the answer to your problem. Okay? Is this clear? One last question for today, and we'll call it a day. Question. There is a semicircular track, and everyone can see the semicircular track, right? And this has a radius capital R. There is a block which is initially placed at rest on the topmost point of the hemisphere. Okay, if this body is given a very slight push, right? If the body is given a very slight push, then question is, find the point where the block loses contact with the track. So basically it will keep on sliding. At one particular instant will come certain angle where this object will leave the track, and it will move like this, right? It will move in a projectile motion like this. It will fall like this. It will leave the surface of this particular thing, and you need to find out that particular point. So take your time, think.
So could you explain again?
The question is, okay, there is a small block of mass m which is placed on where? At the topmost point of this semicircular track. I release this block from rest, that implies the initial velocity is 0. Okay, and at one particular instant it leaves contact with the track. Find the angle theta where it leaves the contact with the track. That is the point. Please remember, whenever I say contact lose kar dega, so here the normal reaction at the point where it loses contact will be how much? 0. Wherever it will lose contact, the normal reaction between the two forces becomes 0. So दो forces को 0, normal reaction को 0 कर देना. But for that, draw the free body diagram, apply work energy theorem, and you will get your final answer. You need to apply work energy theorem, and also you need to apply कैसे करेंगे? By LOC. Let's say this point is A and this point is B. Can anyone tell me what is the initial kinetic energy? Can anyone tell me what is the initial kinetic energy?
0.
The initial kinetic energy is 0 plus. Where shall I take the reference? At point A or at point B? Which shall be the reference?
So point A, I'm guessing.
Point A per reference ले लेते हैं. Okay, so what is the potential energy at point A?
So maximum will be m.
Acha,
No.
whenever it is reference, the potential energy is minimum at that point, and that is 0. Reference पे हमेशा 0 लेते हैं. Right or wrong?
Yeah, yes, sir.
So kinetic energy at point A plus potential energy at point A, दोनों 0 is equals to. Now, what is the kinetic energy at point B? Let's say at this particular instant it is moving with a velocity v. So half m v square plus. Can you see now point B is lying below the reference? So what is the potential energy of this thing? Minus of mgh. Whenever it is lying below the reference, it is minus. Whenever it is lying above the reference, so plus. So it's always a best choice to keep the bottom point as your reference. Okay, so that this potential energy at point A would have come positive. If you would have chosen reference at point B, then this energy would have become 0 and this energy would have come mgh. So can you see, if I move it to the right hand side, again it's the same thing. right? So mgh is equals to half mv square, m से m कट जाएगा, and v square will be equals to twice of gh, which will be twice of g into r into 1 minus. Once you got the velocity, you can find out the normal reaction. So at this instant, when it is at a velocity v, since it is losing a contact with the ground, then the normal reaction is approximately 0. mg was acting downwards, so here will be mg cos theta. Why, sir? Because this theta, then this will always be theta. What do you call it? Alternate interior. So n minus mg cos theta is equals to mv square by r, and from here, can you see n to became 0? Oh, sorry, my bad. Mg cos theta minus n is equals to mv square by r. The radially inward force minus the radially outward force is basically the net centrifugal force. तो ऐसे करके इसको 0 कर दो. So mg cos theta is equals to mv square by r, and the m will again get cancelled. G cos theta is equals to v square, which is twice of g r into 1 minus cos theta divided by r say g, and from here cos theta is equals to 2 minus 2 cos theta. This 2 cos theta will go over here, become 3 cos theta, and from here cos theta will be equals to 2 by. So when theta is equals to cos inverse of 2 by 3, at that instant of time it will lose contact. Achha, by the way, this is 131 minus 180 कितना होता है? 49 degree, right? So this is 49 degree approximately. Is this clear, guys? Is it clear? So that's it for your work, power, energy. Complete thing is done. JEE advanced level also done. Okay. So next class we'll start with system of particles again. What's the time now? Oh, still 10 minutes left. Hello, good. Please note it down. At 10 minutes पहले छोड़ो फिर. In the next class, we'll start with system of particles again from where we left. Okay. Or shall I give you one more question on this?
No, sir, please.
बस.
Early break.
अच्छा. चलिए ठीक है.
This is morning class, please.
Yes, sir.
चलो
Sir,
ठीक है.
too much physics for one day, sir. Please.
Hey, it's okay. It's only 1 minute for 1 hour. 1 hour and how much? 20 minutes.
How much? 20. Sir, we have 3
Sir,
classes and that on Fridays, sir.
So Friday school की छुट्टी है. That's why.
School, sir, Friday is supposed to be on holiday.